These are the 14 times Neil deGrasse blew Joe Rogan's mind with his baffling thoughts in JR Live podcasts, starting with a segment in Joe Rogan Experience number 919, in which Neil deGrasse shook things up when he talked about infinities that might eventually cause an existential crisis. When he delved into infinities, it turned into a sort of conversation that could make anyone's brain short-circuit. And the same occurred with Joe. The conversation began by Joe sharing a classic idea of infinity. If infinity really exists, then it wasn't just him and Neil, but an infinite number of versions of them, revising the same conversation time and again, forever. In response, Neil dropped a bigger bombshell which caught Joe off guard.
If there is really an infinity, there's not only a you and an I, but there's a you and an I and everybody else we've ever met, and all the exact events in the exact same order have gone down an infinite number of times, including this conversation.
Okay, except. There is, I don't know how many people know this, but often it's mind-blowing when you learn that some infinities are bigger than others. Joe Rogan just leaned 2 feet away from the microphone.
As soon as Joe collected himself, he inquired about how some infinities could be bigger than others. In an attempt to make Joe understand, Neil brought up a childhood game. What's the biggest number? In which kids often used exaggerated answers to win the game.
Size.
But if it's infinity, then it's infinity. It's infinite. What is, no?
Okay. Don't you remember when you were a kid? They said, what's the biggest number you know? 1,000,000. Well, there's 1,000,001.
Right.
Okay, how about a billion? Well, it's 1,000,000,001. The annoying kid always added 1 to it. Okay, how about infinity? Well, infinity and 1.
Right.
Okay, well, it turns out infinity and 1 and infinity are the same number.
To make things easier, he dragged math into it. Neil gave examples of counting, irrational, and transcendental numbers, connecting them with the fact that many of these are super infinite.
So, for example, the number of counting numbers, so 1, 2, 3, up to infinity, okay?
Right.
The numbers you would use to count things, that's infinite. The number of irrational numbers, so the numbers that you cannot represent as a fraction, okay? There are more of those than there are counting numbers.
Whoa.
By far. So these are orders of infinity. Then there are more transcendental numbers than there are irrational numbers.
What's a transcendental number?
So that's a number that you'll never find as a solution to an algebraic equation. So pi is a transcendental number, e is a transcendental. These are magic numbers that show up in mathematics. And turns out there's like an even bigger infinity of those than there is of these other 2 classes of numbers. And they use the Hebrew letter aleph in ranking. So it's aleph 1, aleph 2, aleph 3, aleph 4. I think there are 5 levels of infinity. So my point is, just because there's infinite universes, to me, doesn't mean there's infinite conversations that have happened. And I'd want to really explore the depths of infinities before I say and agree with you that this conversation has happened an infinite number of times.
Joe finally admitted that his brain couldn't process that information, while Neil casually stated a line from his book, Astrophysics for People in a Hurry.
Your book.
Epigraph of the book.
Book is not available yet, but I have a copy. Ha! Astrophysicists for people in a hurry.
Astrophysics.
Physics for people in a hurry.
But you got to say it right.
Astrophysicists for people in a hurry.
Here's
you come over to their house. Hey, what's
up?
Here's
it's called Astrophysics for People in a Hurry.
Oh, you got to say it quick.
You got to say because you're in a hurry. So the epigram on that is the universe is under no obligation to make sense to you.
That's rational.
And I've tweeted that before. And so it makes sense to you that the universe is under no obligation to make sense.
Yeah.
Neil had made it clear that just because something seems impossible doesn't mean it's not true. Even the math itself proves it by mapping, which involves putting 2 elements together from 2 different infinite sets. This shows that one infinity outstrips the other, proving the point why some infinities are bigger than others. And just when you think Neil is done with his baffling disclosures, he did it again. This time, he brought something as basic as water. In Joe Rogan Experience, number 1347, Neil talked about air pressure and its unseen power to alter the rules of boiling. As Joe asked him about the reality of dry ice, Neil ended up uncovering the surreal relation between the air pressure and boiling point, leaving Joe speechless as ever.
If we had much higher air pressure, you could have CO2 melt and have liquid CO2. So now watch what happens. So can I blow your mind again? This is this is really good stuff, okay? It's good like physical chemistry. So here you go. So watch what happens. So what happens if I reduce the air pressure? Okay? Well, the transition from ice to water is still the same. It's not affected, but the boiling point is affected. As you know, cooking times have to be adjusted on mountaintops because when you boil water, it's not 212 degrees. Depending on the height of the mountain, there's less air pressing down that's preventing it from boiling, okay? The boiling point is not some absolute fact about the water. It has to do with what the air pressure is sitting above it. If you have extremely high air pressure, water has to go to a much higher temperature before it boils. So the boiling point of water that's reported in all textbooks is at sea level, at 1 atmospheric pressure. That's how you get 212 degrees. If you start reducing the atmospheric pressure, it's 210 degrees, 205 degrees, 200 degrees, 190 degrees, 180 degrees.
180 degrees?
Oh, yes. And so that's not as hot as 212 degrees, so you got to cook the food longer. All cooking times are increased for this reason.
So it concluded that if there's low pressure, water molecules can turn into vapor easily, which means water boils at low temperature. At the summit of Mount Everest, which is 29,000 feet or 8,849 meters high, water boils at just 70 degrees Celsius. This is because of the critically low atmospheric pressure, 33.7 kilopascal or 0.33 atmosphere, which is around 1/3 of sea level's pressure. Neil wanted to prove it by using the simplest way possible. He proposed the idea of doing this experiment in a lab, where you could continue to reduce the pressure with the boiling point dropping on its own. At one point, there will be a situation where all 3 states of water will eventually coexist. To make it even more brain-twisting, Neil said Mars is the place with this extraordinary quality.
Yeah, or take it up, you can ascend in some kind of copter or some kind of device, or air balloon, or whatever. But I'm saying you can do this experiment in a laboratory. Okay? You keep reducing the air pressure. Boiling point keeps dropping. It's 170 degrees, 150, 120, 100 degrees Fahrenheit, 80 degrees Fahrenheit, 50 degrees Fahrenheit, 40 degrees Fahrenheit, 32 degrees Fahrenheit. Holy, what happens? The ice melts and becomes water. The water evaporates and becomes steam, and all of that's happening at 32 degrees. There is an atmospheric pressure for which water, ice, and steam coexist, and it's called the triple point of water. And all ingredients have a triple point.
Wow. What is the atmospheric pressure?
Mars is very close to the triple point of water.
The triple point of water is one of the odd yet coolest phenomena in physics. This point is the perfect temperature and pressure for water to exist in all 3 forms: solid, liquid, and gas. This phenomenon occurs exactly when the temperature is 0.01 degrees Celsius, with a pressure of 611.73 pascals. And, once again, Neil had at it with the infinities, but this time it was about the jaw-dropping multiverse theory, which goes beyond the normal human thinking. During the Joe Rogan Experience 1904, Joe asked Neil about the Big Bang, which the scientists believe the universe started as nothing but a single point, which continued to stretch and expand. The response from Neil was heavy as ever. He said that the Big Bang is the birth of space, time, and energy, and everything we know and love about this universe. According to Neil, this mind-boggling phenomenon started 16 billion years ago, and no one had a clue about what went down before it. As he explained the Big Bang, he brought up something even more startling: multiverse.
The Big Bang. So, we have top people working on trying to resolve this singularity problem. And in so doing, you get to some ideas that, well, maybe our Big Bang, because the Big Bang is not going to go away. All the data support this. So now I've got this Big Bang thing, okay? And, well, is this embedded in something bigger? Ooh. So when you put like quantum physics and general relativity and you try to come up with some bigger understanding, deeper understanding, string theorists have been all into this, you get a multiverse. We didn't pull that out of our ass. That came out of the equations. So how old is the multiverse? I don't know. It's definitely older than our universe because it birthed our universe and it births other universes and it births, the way the equations drive it, an infinity of universes.
So, if the multiverse does exist, then our universe is most likely a tiny bubble in an infinite sea of other universes. Since the multiverse is infinite, it is possible to have every possible outcome existing in other universes. For example, in one universe you're a billionaire, another one has dinosaurs which haven't gone extinct, and even a universe which is acting in the exact same way as this. Neil explained it in the same way in the podcast.
Also a version where everything's the same.
Where everything would be the same, yes.
Everything you've ever said has been said before exactly in the same order.
Correct. There's no reason to presume that everything in this universe isn't or hasn't already played out in the exact way in another one of these infinite universes.
And in an infinite number of different ways.
Correct.
Another mind-blowing possibility of infinite multiverse is quantum immortality hypothesis. As per this theory, in a true infinite multiverse, no one gets to experience their own death. It's because whenever there is a life or death situation, the universe divides into several possibilities. In one universe, you will live, but in the other, you won't. In your own perspective, your consciousness will extend beyond death in the universe where you lived, because if you had died, you wouldn't be able to feel it. But you would feel Earth's flat surface if you were a cosmic giant. This was another shocking revelation by Neil in Joe Rogan Experience 1159, which might rewire your brain and leave you as shocked as Joe himself. Neil discussed the shape of the Earth, which is an oblate spheroid. This means that it widens a little at the equator while flattens at the poles because of the rotation. Moments later, Neil dropped a shocking fact, linking the Earth with a cue ball.
Do you realize if you took Earth with all of its mountains, valleys, and hills and shrunk it down to the size of a cue ball, it would be smoother than any cue ball ever machined?
Really?
Yes. Yes. Think about it.
What?
Think about this. Joe.
Really?
Joe.
Everest?
Joe, chill.
God.
Listen to me.
Damn.
You ready?
He went ahead and let out an even more unexpected truth about the deepest and the highest part of the Earth.
Do you know the deepest part of Earth's crust?
No.
The Marianas Trench, off the coast of the Philippines, in the Pacific Ocean.
That's the deepest part.
Deepest part. It goes 6 miles down. Okay?
Oh, okay. So, okay. I was thinking of the depth of the crust itself.
No. Just access to the deepest part of Earth's crust, the lowest point on Earth's surface, the Marianas Trench, right off the coast of the Philippines. The highest point on Earth's surface, the tip of K1 of
K2. Is it K1 or K2? Which one? Is it Japan?
I think it's K1.
That...
Why would you name the tallest peak K2?
That's a good point.
I'm just
right.
I'm not a mountain climber, but I'm just thinking.
Where is K1?
K1, it's the Himalayan mountains.
Okay.
In Nepal. Okay? Isn't it in Nepal? I think it is.
Yeah.
Yeah. Okay. So now let's say, how high up is that? Well, it's 28,000 feet. So it's like 5 miles up. Okay?
What's even more surprising is the distance between these 2 points, which is way less, and you could drive that distance in just 15 minutes on the highway. To put it simply, the distance is considerably small if it is compared to the overall Earth size.
The distance between the lowest point on Earth's surface and the highest point on Earth's surface is 11 miles.
That's here to the Comedy Store.
That is less than the length of Manhattan.
Whoa.
Yet we are 8,000 miles in diameter. And those 2 points are very far separated from one another. If you were a cosmic giant and you came up to Earth and you rubbed your finger over Earth's surface, it would feel as smooth as a cue ball to you.
If someone stands on the summit of Mount Chimborazo in Ecuador, they will be more distant from the Earth's center than on Mount Everest. It happens because Chimborazo is near the equator, where Earth sticks out. So even though Mount Everest is the tallest above the sea level, Chimborazo technically becomes the farthest point from the Earth's core. Looks like the Earth's shape and surface smoothness aren't the only best-kept secrets. Because in the Joe Rogan Experience 919, Neil casually mentions another jaw-dropping shocker about something as small as an electron. Neil was telling Joe about the possible occurrence in the center of the sun, and that the matter on the sun can be affected by temperature and pressure. Unsurprisingly, it is impossible to visit the sun's surface and witness it directly. So, to see the possible reactions in the sun's core, anyone can pull these sort of experiments in a laboratory. Joe mentioned the things that we can observe, which are atoms. Moments later, Neil decided to keep Joe on his toes with an unknown fact about electrons' size. This shocking truth forced Joe to clutch his head.
One of the things I will tell you in it, and I'll tell you now, the electron has no known dimension. It is smaller than the smallest we have ever had the capacity to measure. So as far as we are concerned, it is infinitely small.
Whoa.
We have no way to even know how to measure. By the way, how do you measure something small? You get something smaller and find out how many of those it is.
Oh, my head. My stupid head.
Think about the challenges at each extreme. Ask me how big is the universe, and I'll say it's as big as, well, I got nothing. What am I going to say?
According to the experiments, scientists confirm that electrons are point-like, which means they are zero size. But it seems hard to wrap your head around because how can something with zero size have mass and charge? So, quantum mechanics says that an electron acts like a probability cloud. This implies that the electron stays in the fuzzy region of space and not in one fixed place. Scientists have conducted a bunch of experiments going down to trillionth of a trillionth meter, and they haven't come across any limit. So basically, an electron is so vanishingly tiny that even after numerous powerful experiments, no one could measure its size. Coming back to podcast, Joe ended up shifting this shocker to another side, asking if there's a possibility of almost impossible, presuming that subatomic particles may have their own universes inside them. Neil's take on this was just as good as always.
Really, at the biggest end, the littlest end of the same thing, meaning that at the smallest measurable point, that literally might be a whole nother universe that might be fractal.
It's fun to think about. It's all the way down.
Yeah.
It's fun to think about.
Infinitely down, down.
However, and people, by the way, in the 1920s, when we discovered the atom and its structure, and that there's an electron in, quote, orbit around a nucleus, it was like, wait, we've been there before. We got planets orbiting the sun. And so so maybe it's a mini solar system. Maybe it's solar systems all the way down.
And this was where Neil left it there, with no clear answers, taking off to an existential rabbit hole. The same Joe Rogan Experience 919 witnessed another startling fact by Neil DeGrasse Tyson. It all began with a discussion about space stations, which are artificial habitats hovering around the Earth's orbit for astronauts to live and work for a long time. Neil explained to Joe that space stations are usually at 1g, or 1 gravity on the edge, but they are actually 0g. 1g is the type of gravity we experience on Earth. 0g occurs when there is no obvious gravitational force around you, but gravity is still there. The 0g thing on the space station is achieved when it is in a continuous loop of free fall toward the Earth. This makes the astronauts inside the space station feel like floating.
Is it possible to generate gravity in a space station?
Only if you rotate it.
Only if you rotate it.
It's not gravity, it's simulating gravity. But according to Einstein, they're indistinguishable from one another, so you can do it.
So it is possible to do something where you can send people into deep space and generate gravity through some sort of rotation?
At least two ways. One of them, you just rotate it.
After Neil explained much more about different types of space stations, Joe told him about a famous astronaut who struggled with gravity after he returned from his long space trip.
Right.
Right, and there's some that have rotating opposite ways so that they can spin up against one another, right? And so there's some clever ideas out there with space stations of the future for long voyages.
Because I had Commander Hatfield on the podcast,
Cool.
who came back from space and was talking about the excruciating difficulty he had readjusting to gravity after being in a zero gravity environment for so long.
He's just showing off because he's like setting records for being.
Wasn't he like 6 months?
Yeah,
I
it was a
believe?
long time. He's showing. Yeah, I couldn't handle life with you lowly Earth people.
He was talking about his body. Like it took like over a year before his bone density came back.
Now, to make Joe understand the possible after effects of staying in zero gravity, Neil mentioned a science fiction movie, which is both scientifically right and mind-expanding. It was that moment that Joe's mind was truly blown.
What's the name of the movie? It's
recent.
Yeah. Oh, the Space Between Us.
Oh, what the hell's that?
You got to get out more, dude.
I do.
Yeah.
But that's
So
beside the
this is
point.
a Martian colony where the first community.
What movie is this?
This came out a couple
When?
of months ago.
Really?
Oh my gosh. Oh yeah.
Oh man, I'm so behind. Is
that's
this out on iTunes yet?
So that's the Martian colony,
I'm gonna write this
and one of the female astronauts they send, that one there, happens to be, they learn, is pregnant, and they can't bring her back, and so she gives birth on Mars, and the
Jesus.
first person who is ever born on Mars. And then they keep it a secret, and then he comes back as a teenager that falls in love. See, there's the fetus. So anyhow, he has a hard time on Earth because his heart developed in Martian gravity, which is only 38% Earth gravity.
Oh wow.
And then on Earth, he just couldn't. They had to, figure out what to do with him.
Wow.
Yeah, that's on
Intense.
Mars. The kid was born on Mars.
Okay.
The movie, The Space Between Us, shows the true side of what would happen if someone were born and raised in space or any planet other than Earth. Since Mars has only about 38% of Earth's gravity, the person raised there will eventually develop weaker bones with less density alongside a weak heart. It might even be highly challenging for this person to live on Earth. But what about the junk that's been piling up non-stop in the space? In Joe Rogan Experience 1159, during an eye-opening discussion about space wars, Joe asked Neil about all the space debris that's been taking rounds around the Earth. Hearing that, Neil appeared to be driven about cleaning the junk if the Space Forces come up with any solutions. Jamie quickly pulled up the Air Force website where the space debris was being tracked in real time. Looking at all the data, Joe was truly stunned.
You would, yeah. That's not the debris. Those are the satellites.
Yes.
So, if you, no, that is debris. No, you got it. So the Air Force tracks debris, as does NASA. They both track debris, and sometimes launch windows of spacecraft.
Pieces that's floating around.
Pieces.
Look at that. That's crazy. Are you scrolling through all that?
I'm going as fast as I can.
Oh my God, that is so nuts.
Yeah.
We're so crazy.
He then moved towards the history of space junk, which was surprising enough for Joe to leave him speechless. The information about how space had only one satellite back then and later, it turned into a dumping ground for endless debris, doubled Joe's disbelief.
So you track it, right?
When was the first satellite?
For satellite was Sputnik. Excuse me.
What year? But when
Excuse me.
was
How,
that? 60?
You're too far away from me to slap you.
Oh, sorry. Sorry. What was it?
Sputnik, October 4th, 1957.
57.
The first artificial anything in orbit around the Earth, and on that
that
day
piece of shit still up there?
There was only one thing.
One thing, only then.
Only.
Wow. From 57 to 2018.
Right. So it's 60 years.
Wow.
Yeah.
One thing. That's crazy. And now, how many things?
Well, there's
You gotta
the
guess.
countless debris. There's hundreds of active satellites. There's thousands if you include the dead ones.
Sputnik 1 was the first ever artificial satellite launched by the Soviet Union on October 4th, 1957, in space that reshaped the world. It was a small metallic beach ball like a satellite about 23 inches in diameter and weighed around 184 pounds. Surprisingly, this satellite kicked off the space age and the Cold War space race between the United States and the Soviet Union. Sputnik 1 stayed in the space for 3 months before being burned up on January 4th, 1958. According to the Forbes article, there were around 10,036 operating satellites in July 18, 2024. And in Joe Rogan Experience 919, Neil pointed out that growing space junk, which is currently more than 10,000, can cause big hurdles for future space missions. While discussing the ways of generating the gravity in space, Neil suggested a new, innovative way to arrive in space more quickly.
Another way is if you're headed somewhere,
Right,
you
like
just
Mars.
have a huge fuel tank and just always run your rockets.
Oh,
Then
so you
you
always
just
have
accelerate it.
G-force.
There's always a G-force.
Oh,
so if you
interesting.
accelerate it 1G
Right.
towards a destination, then you'll
You'll
always
always have
feel
1G.
Earth gravity, and you'll get there
Ah.
awesomely fast.
But you would have to have so much fuel or
Yes, you'll
rely
need
on something
well, you
new.
need filling stations en route, this sort of thing. And if you do this, you accelerate 1G halfway there, then you turn the spaceship around, then you decelerate at 1G for the other half of the trip, so that when you get there, you're not whizzing past it in a flyby. Okay? That way you have 1G the whole trip. That's how you would do that.
Wow. So the momentum when you would precisely hit
If you accelerate
halfway
it
there.
at 1G, oh my gosh, you hit near the speed of light very quickly.
But for that 1G, the rocket would need a continuous acceleration of 9.8 meters per second squared. This is the exact same force we experience as gravity on Earth. But if we see it practically, it is almost impossible to achieve this because rockets burn fuel within a few minutes. To fix this, scientists could choose an alternative like antimatter or fusion propulsion, but these technologies haven't come out yet. The last resort could be the use of rotating spacecraft, which can form artificial gravity using centrifugal force. The sci-fi movies Interstellar and 2001: A Space Odyssey are the best examples of this type of spacecraft. So, when it came to making towards the space at the speed of light, Joe's mind clicked, and he dropped the most awaited question. What if the spacecraft or spaceship crashes into something on its way to space? This question pushed Neil to lay bare the unsettling truth.
What happens if you just run into stuff on the way? Like,
That's
there's
bad.
a lot of stuff out there, right?
Yeah,
I mean,
so
isn't that a giant issue in getting to Mars?
Well,
all the
space
stuff?
is actually quite empty, but if you do hit something, that's the end of everything. So it's a low risk, high consequence thing that
Right.
you gotta put in play.
Now, how much of a risk is the space junk that we've left in the environment?
Oh,
'Cause
don't get
we
me started.
We were
Oh.
freaking out the
Oh,
other
we
day
got
about
so-
how many
we got
pieces are up there.
There's countless thousands of bits of space junk.
Yeah.
From chips of paint that fell off of
To
space
bolts.
to bolts and nails and
Retro rocket boosters and-
Yeah, it's all up there, and I'm wondering whether we haven't been visited by aliens yet because they saw the space junk orbiting Earth and said, "Forget that. I'm going to visit some other planet. I'm
What
not
a-
going to risk my life."
Crazy short-sighted approach to space travel.
Yeah,
to
so if you
litter
bring
our...
up the NASA Orbital Debris Office website, you can actually see the debris that NASA's tracking, almost in real time.
It's crazy
They'll
how
show
much
it to you.
there is.
And it's like a beehive around the Earth. So you got there it is. Okay, that's the debris around the Earth that NASA tracks.
By checking out the images and videos available on NASA's website, the launch window can be set up accordingly.
Just see the movement of these pieces, and it's so launch windows have to know when to not hit stuff. So,
geez.
so when you have launch windows, it's not just is everything aligned right, will you successfully get past the debris.
Joe seemed to be worried about the space debris and mentioned the famous space debris cleaning project, which was unfortunately failed. At this moment, Neil revealed the chilling reality about the speed at which debris is whizzing around the Earth.
And there was a Japanese, they had an experiment to try to capture it with nets. It was a recent mission.
Oh yeah, so
Didn't work.
Yeah, so the problem is the low orbit stuff will eventually fall in and burn up. The high Earth orbit stuff will never go away. There's nothing to destroy it.
And so they can't capture that stuff?
Well, you need a very clever. This stuff is moving 18,000 miles an hour. So what's your net? What are you doing?
That's so crazy.
This was JAXA's Japan Aerospace Exploration Agency Kunotori 6 mission, which failed badly. The project involved the making of a space garbage collector, a fishing net to pick up the debris. After showing a video of orbital debris to Joe, Neil shared the dark and scary truth.
Go higher res on that. Sure, I know there's a higher res.
Oh, God.
That's 1080? No, it's not.
It's not from NASA's YouTube panel. It's from
Somebody else. But that's the kind of, so all of that's debris that you're looking at there. So anyway, yeah, so your concern for debris is well placed. And we may be putting so much debris in space that we will close ourselves off from space travel because of the dangers it would take to get through our own garbage heap.
That's so crazy.
While space junk and its dangers remain outside the Earth, Neil deGrasse Tyson noted the biggest direct threat for Earth: asteroids and meteorites. In the Joe Rogan Experience 1159, Neil unraveled a bigger issue for people on Earth. He recalled a major meteorite event that shook people to the core, leaving a great deal of people injured.
There was this asteroid that collided with Earth over Chelyabinsk in the Soviet Union, in Russia, sorry, just near the Siberia, in the Ural Mountains, just on the coast of Siberia, on the border of Siberia. That was visible to everybody in broad daylight, and you had to like avert your eyes when it happened. And they felt a shockwave, and the shockwave broke windows and sent 600 people, nearly 1,000 people to the hospital. What happened? Well, because they saw the light, and they got up from their table and went to the window to see what had happened, there's a time delay between the shock wave and the light, because light travels fast and sound travels slow. So they'll go to the windows, and the shock wave hits, and it blasts broken glass into their face. So it's a big Band-Aid collision that we had.
Wow.
The injured people all needed basically Band-Aids. Okay, no one died.
This meteorite that hit Chelyabinsk, Russia, on February 15, 2013, was 20 meters in diameter, a perfect size of a small house, and weighed 14,000 tons. Surprisingly, it was traveling 68,000 kilometers per hour. Since the meteorite was hurtling towards the Earth with too much pressure and heat, it burst mid-air 30 kilometers above the ground. This explosion had produced 400 to 500 kilotons of energy. The craziest part of this event was that this meteorite hit was totally unexpected. It was because it came from the direction of the sun, where telescopes don't seem to spot anything. The Chelyabinsk meteorite event gives a reminder that Earth can be hit suddenly without warning. Neil told Joe that the meteorite could have caused a worldwide impact and led to the extinction of humans. Neil had also bought himself the fragments from that Russian event as a scary reminder.
Nearly 1,000 people were injured. So at an auction, by the way, that actually exploded and pieces of it were recovered. At an auction, I purchased a piece of that meteorite, but you know what else I purchased? Some of the shards of glass that the shockwave had broken.
What do you do with this?
I've got it. It's just, I have it. I'm a part of, it is a shot across our bow. That's what that, no one died.
But it's a warning.
There's no better way to be
Wake-up
warned than to have a Band-Aid cover your injuries that could have vaporized you or rendered your species extinct.
Shortly after, Joe and Neil shifted their conversation towards another major Tunguska event.
That don't even make impact and still do devastating damage,
Yes.
like Tunguska.
Yes, that one didn't even touch Earth.
Yeah.
Right. It incinerated 10,000 square kilometers of forest.
Look at that
Right.
honk. Holy.
During the same Joe Rogan Experience, Neil revealed an interesting fact about microwaves that many aren't aware of, including Joe himself, and he found it truly fascinating. While they were conversing about the reheating of food using a microwave, Joe asked Neil about the possible side effects of microwave radiations.
Don't worry about it. It's not doing anything to it. It's not sucking any nutrients out or adding any nuclear radiation.
Correct.
Okay.
It has nothing to do with radiation in the normal sense, other than electromagnetic radiation. It's already light from the bulbs. We tend to use radiation in the context of stuff that would hurt you. So that would be radiation of high enough energy to hurt you, and microwaves are not in that category.
I never even thought about what microwaves do until this conversation.
Neil then moved towards how microwaves work in general, adding to Joe's surprise. Joe didn't know why the utensils inside the microwave do not heat up but the food.
Microwaves that beautifully pairs with the water molecule, and it vibrates it brilliantly.
So it doesn't work for completely dried things?
Yeah, that's why if you put something that has no water in it, it's not really very useful.
What happens if you
it's
do
why
beef jerky?
It's there's,
Must
still,
have a little
there's still
moisture.
some moisture in it, correct.
Yeah.
It's why it heats the food and not the plate. If the plate gets hot, it's not because the microwave oven heated the plate. It's because
the food's hot.
hit the food, and the food. That's why you can usually pick it up at the handles. You can cook food on a paper plate.
That's
Oh my gosh.
right.
Oh, yeah.
It doesn't burst into flames.
Doesn't burst into flames.
This is crazy.
Microwaves use radiation around 2.45 gigahertz to heat the food by triggering the water molecules inside the food. Megatron releases microwaves inside the microwave ovens, which continuously bounce through the oven to heat the water molecules. Other than water molecules, microwaves also come in contact with fats and some sugars, causing vibration and friction. This ends up generating heat in the food. And since the utensils made of glass, ceramic, and plastic do not have water molecules, they don't get heated up during the process. Thus, the microwaves easily pass through them, reaching the food inside. But metal utensils aren't the same. Metals reflect the microwaves instead of taking them in, which may cause sparks or flare up. But the danger isn't limited to the sparks in the microwave. The raw power behind the moving objects is equally dangerous. In the Joe Rogan Experience, 919, Neil discussed the kinetic energy, which sometimes can be unexpected and explosive. It all began with the topic of China destroying its own satellite in space. Neil told Joe that if someone wants to destroy something, they wouldn't need an explosive. The only condition would be that the projectile is speedy enough to cause a self-explosion. And that's what China did. It was a strategy named as kinetic kill.
So a kinetic kill, for those who don't know, is you don't need explosives if the speed of the projectile and its kinetic energy is higher than the energy that would be in the explosive shell itself.
Oh.
So it's a fascinating calculation to make. So here it is. So I have this delivery system with a warhead, and I put some bomb device in the warhead, and you can calculate how much energy that is. Then I send it, and it hits, and it blows something up. But suppose I send this thing really, really fast. Really, really, really fast. I can calculate how much kinetic energy this thing has. There will be a point where I give it so much kinetic energy, the kinetic energy is greater than the chemical energy of the conventional explosive that I put in the warhead.
China has been making kinetic kill weapons which are used to take out enemy satellites through direct impact without the use of explosives. In January of 2007, China did a test project on these anti-satellite weapons and used a SC-19 missile to wipe out its own aging weather satellite in low Earth orbit. The wildest thing about this test project was that this projectile clash brought about 3,000 pieces of space junk, worsening the already bad space junk situation. Due to this, it was considered controversial because it could threaten other satellites and the International Space Station. Shortly after conversing about this, Neil turned toward something more deep. He mentioned the craters on the Moon, which many scientists believed were due to calderas. But it was far from the truth.
The argument for the longest time that the craters on the Moon were calderas from volcanoes and not asteroid impacts. The geologists argue strenuously these can't be asteroid impacts. They've got to be calderas, these 1,000 craters on the Moon. Well, why? Because everyone is a perfect circle. And if asteroids are coming from space, they would come from all angles. And if you come in at a shallow angle, you get an oval. And even shallower, it'd be more ovals. So you'd have a whole range of circles and ovals and ellipses. And you don't see that. They must be calderas. It was not
Explain
until...
a caldera. It's a volcano.
Oh,
that
just a
explodes
volcanic...
and it leads a crater.
Volcanic crater.
To explain why every single moon crater was a perfect circle, Neil shared a lesser-known fact about kinetic energy, surprising Joe to the core.
In the 1970s, we were able to do calculations with high-speed computers, with good computers. And what we found was, if the object is moving faster, if the kinetic energy of the object is higher than the energy that's holding the thing together. Ooh. Okay? So what's holding together a rock? The chemical connections of the silicon and the oxygen and everything, and the iron, everything that's making the rock, that's holding it together. You can calculate how much energy is holding it together.
And if it's going 45,000 miles
So
an hour.
write down that number. Now I send in the asteroid with a kinetic energy higher than the energy that's holding it together. On impact, it explodes. Because all that energy goes back into the rock because the thing isn't moving anymore. Where did the kinetic energy go? It digs a crater, number one, by virtue of putting all that energy back into the stone, and that explodes it. So on impact, even at an angle, it is a singular point explosion. And that's why every single crater is a perfect circle.
So it isn't only about spacecraft, space junk, and mind-bending scientific theories. Neil had something new for calendar stuff as well. While talking about the leap year in the Joe Rogan Experience 1159, Neil uncovered the truth about the Julian calendar.
Right.
Okay? Well, who invented the calendar we all currently use in modern society? It's called the Gregorian calendar. It was invented by the Catholic Church, by Jesuit priests in the 1580s, assigned by Pope Gregory to fix the problems in the calendar because, I'm sorry, I'm screaming at you here. You got me started.
Scream. Get crazy.
I gotta calm down.
I'll bring in coffee.
The Julian calendar, put forth in ancient Rome, had one modification to previous calendars. It had a leap day. Okay? It had a leap day.
Julian calendar followed a 365.25 solar year. This means it had one leap year added every 4 years to make up for the extra 0.25 days. But this ruined the accuracy of the entire calendar. If we look at the actual length of a solar year, it is 365.2422 days and nowhere near 365.25 days. Even though the difference was as tiny as 11 minutes, it made a big blunder. Due to this, the religious holidays like Easter continued to drive away from the spring equinox. At the end of the 16th century, the Julian calendar had missed 10 days.
That by the year 1584, the vernal equinox, the first day of spring, did not occur on March 21st. It occurred on March 10th. It shifted from the calendar date. That's what happens if you don't match the cycles of things. And the Pope said, we're not having any of this, especially since Easter might land on Passover, and we're trying to distinguish ourselves mightily from the Jews. So let's fix this. The Jesuit priests got to study this. They looked at the cycles of the heavens, the sun, the moon, the stars, and they came up with a new calendar, the Gregorian calendar, a modification to the Julian calendar.
Neil turned to explain how the Gregorian calendar fixed the missed 10 days and leap day blunders, which was quite surprising to say the least.
The Gregorian calendar figured this out, and it had put 10 extra days since the Julian calendar to the Gregorian calendar. 10 extra days. First, jumpstart, get rid of the 10 days. Now everything's lined up again.
Okay.
Now, how do you prevent this from happening again? Because it overcorrects, how long do you have to wait to remove a leap day that you would otherwise put in? Okay?
Okay.
That's every 100 years.
Oh.
So every 100 years, that would be a leap day, you remove the leap day.
Oh.
Now, it turns out that undercorrects it
Oh.
by an even smaller amount, okay? So, how long do you have to wait before you have to put a leap day back in? Every 400 years.
Oh, God.
So, the year 2000 was a century year, which normally would not have a leap day, except it's a century year evenly divisible by 400, so they put the leap day back in. And everybody on February, almost everybody except the astronomers, on February 29th in the year 2000 said it's just a leap year because it's divisible by 4. No, it is a rare leap year. It is a century year divisible by 400. That corrects it back, and so now you have a stable calendar for tens of thousands of years. I gotta give props to the Jesuit priests.
It turned out that it wasn't only the ancient calendar that was messed up, because Neil had dropped another truth bomb on Joe in the same Joe Rogan Experience. After learning the jaw-breaking truth about calendars, Joe asked Neil why we couldn't come up with a calendar with no leap years. This was when Joe discovered a truth that left him reeling.
What you would have to do, you could do it, but what would happen is, it means you care more about the year than you do about the day. So what would happen is, you would celebrate the new year at like 3 in the afternoon. Right? And then the next year you'd celebrate it at like 12 minutes after 3 in the afternoon. And then 20 minutes. It would sort of move through your calendar. And then that means you cared more about the year, you cared more about the, did I say that right? We always want to celebrate New Year's on midnight and by the way, New Year's is celebrated in 24 time zones, not all at the same time.
Right.
So it's interesting, everyone thinks of that as a moment.
If we look at this issue at the cosmic level, there's a lot of time difference. Earth moves 360 degrees in one day, or 24 hours, which means that each 15 degrees out of 360 takes about 1 hour to take place. When a part of the world is experiencing the midnight on January 1st, other places are hours behind and waiting to get their clocks tick 12. Besides, Earth's orbit isn't a perfect circle, but more likely an ellipse. Therefore, the time it takes to revolve around the Sun isn't an even number. This explains why it is not 365 days, but 365.2422 days, and that 0.2422 are almost equal to 6 hours. That's exactly how Neil also explained this to Joe.
Huh. So that would be the only way?
Yeah, that's the only way, because a day doesn't cut evenly into the year. Those two have nothing to do with one another. There's no reason why that would have. So so in other words, let me say it another way, just because you're looking like you're looking off in space here. So there's New Year's. Okay, let's count 365 days. When we do that, we are not at the same place we were when we last celebrated New Year's Eve. Okay?
We're not at the same place in our rotation?
In our orbit, our revolution.
Around the sun.
You rotate on an axis, you revolve around something else. That's those two words.
Okay.
How you use those two words. So we're not in the same place, but we celebrate New Year's anyway. Well, when will we be in the same place? A quarter of a day later. 6 hours. So we would celebrate the next New Year at 6 a.m.
Nobody's willing to do that.
No one's willing to, and the next New Year at noon, then the next New Year at 6 p.m.,
Whoa.
and then the next New Year kind of aligns back again. Well, that's the leap day. That's the 4th year we have put in a leap day.
Oh.
See?
So it's our love of the day
Yes.
that keeps us
Yeah.
up with the world.
But this leap year system still has some blunders. Since 0.2422 is 5.8 hours and not 6 hours, it doesn't add up perfectly to a day. To fix this, we skip the leap year every century, except if the century is divisible by 400 like 2000, 2400, 2800, 2300, and so on. And in the same podcast, 1159, Neil blew Joe's mind even further by recalling the times of Columbus and how he helped unite the isolated human species around the world. Neil began the conversation by mentioning how Columbus's arrival in America was so important that it changed everything.
Him coming to America was the most significant thing to ever happen in our species.
Whoa.
Silence.
Not internet porn?
No, that's just porn in another medium.
Right. Wow.
Yeah. So yeah, internet porn is just a matter of degree, not a matter of
Yes.
does it exist or does it not.
Right.
Okay. I think it was the most significant event to happen in our species.
Kind
Joe seemed to not agree with his point, which pushed Neil to explain everything in detail. He started by discussing the Ice Age and the impact of the cold temperature leading to many significant events in history.
So during the Ice Age, the ocean levels dropped, exposing the Bering Strait land bridge between Asia and what is now Alaska, basically North America. Our ancestors who come out of Africa go into Europe. Some stayed, others kept wandering. Some stayed low above the Mediterranean, others went high. They populate Asia. They keep walking because there's a land bridge there. They don't even know it's a bridge, it's just more land. So they walk, and they enter North America. And from there, that's kind of the only way you can go is south at that point. The weather gets a little better. The Ice Age ends. The glaciers melt back into the oceans. The ocean levels rise, closing the land bridge.
Neil then disclosed how Columbus played a big role in the reconnection of human species, but of course it came with a price.
Stranding a branch of the human species for 10,000 years. Those humans who made it across that land bridge and spread out into North America, Central America, South America, have only a few families as their parent genetic origin. Okay? Only it's like some research says it's like 8 family lineages populated the entire North and South American continents. Then the land bridge breaks. Now you have Europe, Asia, Africa, and North and South America.
Many historical records say that a deadly and disfiguring disease called syphilis spread all across Europe in the 1490s, and it was just after Columbus's return from Americas. The scientists named this situation as the Columbian exchange theory of syphilis, which means that Columbus and his crew unintentionally brought the disease back to Old World from the New World. It is believed that they got this disease from the natives of Hispaniola. When they returned to Spain and got into the military service of Charles VIII of France, these soldiers began exposing the local population. Before 5 years had even gone by, syphilis was epidemic in Europe. And even though Columbus's trip into the New World sparked a deadly outbreak, Neil said it was all worth it because it reconnected the stranded human species.
You know, before the land bridge, is whoever was right at the edge of Asia.
Right.
Then the land bridges. So Asians and North American and the natives of North and South America have more in common with each other because of this than most other pairs of groups you might grab around the world. But my point is, obviously, there's a lot to blame Columbus for, but he just happened to be the guy who did it first. Europe was coming to the New World no matter what. Everybody was trying to find a faster trade route to the Indies. And so if it wasn't Columbus, it would have been Arnold Schmednick, whatever. It doesn't matter. Somebody did that. And the rest is, as they say, history.
Wow.
So personally, I think it is the most significant thing to happen in our species. Otherwise, we'd still be 2 stranded branches of humans.
But it might not be true that Columbus introduced this disease. There is a second theory which is called pre-Columbian hypothesis. This theory says that the disease was always there in the Old World. Many argued that this disease never surfaced before the 1490s. But the experts say that no one could tell the difference between syphilis and other diseases with almost the same symptoms. So, did Columbus really bring syphilis to Europe, or was the disease hidden all along in plain sight? The argument rages on. But one thing is for sure. The history isn't as clear-cut as we believe it is.